Hi, welcome back. Today we have a question which is a deflector turns a sheet of water through an angle of 30 degrees as shown there. What force components are necessary to hold the deflector in place if mass flow rate here is 32 kilogram per seconds? So first we need to analyze the question. What force component are necessary? So the question asks, determine the force component. So what are forces involved? We have these forces and this type of force. Alright. Rx and Ry reaction force required to hold the deflector from moving. So the first step, what we're gonna do is we need to find you can see we have the velocity inlet and velocity outlets, right? So according to the principle of Bernoulli equation, and this deflector is exposed to the atmospheric pressure, or in other words we can say that the water on the deflector exposed to the atmospheric pressure, pressure 1 and pressure 2 equal, and this is negligible of elevation, so we can say that velocity 1 is equal to velocity 2 as per the Bernoulli equation, right? So V1 and V2 is the same. So step number 1, we need to find velocity. So step 1 finds velocity from, given here is mass flow rate, from continuity equation. So what's the continuity equation for incompressible? So this is incompressible because this is fluid flow. So mass flow rate, alright, equal to rho AV. Since this is the fixed deflector or stationary deflector, there is no change of velocity from the inlet of the jet coming to the deflector inlet. So velocity 1 is the same with this velocity here. So this can be said that V1 as well. So mass flow rate at 1 equal to area at 1 and velocity at 1. So given here mass flow rate is 32. Replace here 32 equal to density of water, which is as usual 1000. And the area given here is, this is the area. Alright, this is area, cross-sectional area, the rectangular area. And you notice that this is in millimeter. We need to convert to SI unit in meter. So in this case, it is 0.002 multiplied with 0.4 multiply with V1. So finally, the V1 you will get is 40 meter per second. V1 is the same with V2. V2 as well. And step number 2, in order to involve the force here, we have to apply the momentum equation in X component and Y component in order to get the both component. So let's apply momentum equation at X axis. So what is the momentum equation? Which is summation of force in X component equal to mass flow rate V2x minus V1x. So V2 is outlet and V1 is inlet. You notice that this velocity is V2 is lengthening. V2. So in order to get the V2x component, we have to do adjustment, which is V2 cos, this angle is 30, cos 30. And just replace here, the mass flow rate given previously is 32. Okay. And V2, remember, V2x is equal to V2. Then you can replace V2 cos 30 minus V1x. You can see V1x only x component. So we can definitely replace V1x with V1. And summation of force in x component. Do we have any force in x component? Yes, we only have the reaction force in x component, which is Rx, which is pointing to the left. Pointing to the left is negative force. So replace here with negative Rx. Right? And previous step 1, we discovered that V1 equal to V2, which is 40 meter per second. Then we can replace V2 with 40 and V1 with 40. Negative Rx equal to 32. Replace with 40. Cos 30 minus 40. And final answer you will get Rx is 172 Newton to hold the deflector in the X component. Now we find the Rx. How about Ry? We can apply again the momentum equation in Y component. So step number 3, apply momentum in Y component or Y axis. So summation of force here, summation of force in Y component equal to mass flow rate V2, this is Y component, minus V1 Y component. Alright. So summation of force. Do we have any force in vertical direction? Yes, we do. We have Ry pointing upward, which is positive. Positive Ry. Or you also don't have to write the positive sign because everyone in the world know it is positive. Equal to mass flow rate given here is 32, the same. The flow rate will not change. 32 V2Y. So this is V2. We notice that it is lengthening. Definitely we have the Y component. Alright. This is V2Y. How to get the V2Y? We do adjustment V2 sine this angle 30. Alright. So V2, replace here V2Y with V2 sine 30 minus V1Y. Where's the V1 Y component? We don't have any velocity related to the Y component. So we shall omit it, or we can say it is 0. Minus 0. And you solve this Ry equal to, okay, V2, we know that V2 equal to V1, which is 40 earlier. Replace 40 into this equation. Finally, you will get, alright, 640 Newton. Therefore, the final answer is Rx 172 Newton and Ry is 640 Newton. That is the final answer.